last time, and we kind of left off with some stuff that I just kind of made up on my own. Today let's talk about inequalities. Have you had inequalities before?
I don't know.
Inequalities are like equations, only instead of an equal sign, it's a greater than sign, or it's a less than sign, or it can be a greater than or equal sign like that. Okay.
Well, I mean, I haven't had them in school, but you've done them with me.
Okay. The way you solve an inequality is pretty similar to the way you solve an equation. Okay, in other words, you subtract 4 from each side, and then you divide each side by 3. So the next line would be 3x is greater than 60. Dividing each side by 3, I get x is greater than 20. And that's the answer. If I wanted to graph that on a number line, where that's 0, that's 20, well, this is saying that x is greater than 20. So that's how I graph that. I think I did this problem specifically, didn't I?
I don't think so.
Oh, okay. There's one main difference with an inequality as opposed to an equation. And that is if I put a negative sign in front of that. Now I'm going to subtract 4 from both sides, and so I have negative 3x is greater than 60. And now I'm going to divide by negative 3 both sides. Well, when you have an inequality and you divide or multiply by a negative number, you have to change the direction of the inequality. So this becomes x is less than minus 20. And notice that what that means. Here's my number line, minus 20 is way over here, and it's saying x is less than minus 20. So x has to be some number smaller, in other words, minus 21, minus 100, something like that. Okay, so that's really the biggest, the only difference that you're going to have to pay attention to for a while is when you multiply or divide by a negative number, you have to change the direction of the inequality sign. All right, let's do a couple of these. Next line.
2x is less than 20.
Next line.
X is less than 10.
That means less than or equal?
Or equal.
Okay. What's the first thing I can do here?
Subtract 1.
Okay, so that's going to make that a 62 plus x. Next line.
Negative 2x.
Good.
Less than or equal than 62.
Good. Next line.
X greater than or equal to 31. Negative 31.
Good. other words, make sure you do both things. Make sure you divide by a negative and you change the direction of the inequality sign. A lot of times it's easy to focus on changing the direction and you forget to actually divide by the negative, turning your answer negative. Now, when I graph this, there's a slight difference. Here's negative 31 over here. Because it's greater than or equal,
it's going to be filled in.
A solid dot, yeah. And then that goes all the way to infinity, like that. Okay. Now, sometimes you have three terms, like this. And you can treat this just like there were three parts of an equation. In other words, whatever you do to one part, do to all three. If I'm trying to isolate x, then I want to subtract 4 from all three parts, right?
Yeah.
Which would make sense.
So it's going to be...
Go ahead.
2 less than
Greater
x.
than. Greater than.
X less than 0.
Greater than.
Greater than.
0. If you're reading left to right, and you always are, then this is greater than. Okay? If some student once told me how they taught it to you in school, something about an alligator jaws.
Yeah, alligator.
Did they teach you that also?
Yeah.
So how would I graph this? Here's my key points, 0 and 2. Where's my graph go?
1 second. Sorry, my dad's calling me. Sorry.
It's all right. So what does it mean that 2 is greater than x, which is greater than 0? What part of my number line am I going to draw the line in?
It's going to be 2 and beyond.
No, notice that x is less than 2. In
Oh.
other words, there's two ways to read that. You can say that 2 is greater than x or x is less than 2. They both mean the same thing, right?
Yeah.
And in this part of it, x is greater than 0, so it has to be this area right here.
Okay.
With an open circle at both ends, because it's greater than, not greater than or equal. Hold on a minute, I need to close my door here. And I gotta get the doggies out. All right, come on. Come on. There. This way, not so loud for the whole house. Me, okay. All right. Let's get back and do some more algebra. ABX equals C, and I want you to solve each of these for x. What's x equal to?
X is equal to C.
Okay, let's talk about solving equations.
Oh wait, x is equal to a and b.
How do I isolate x? In other words, my goal is to get x down here all by itself, okay? What do I have to do to accomplish that?
Divide an a and b by c.
Divide the left side of the equation by AB. Okay, then those will cancel and I'll be left with x. Well, if I divide the left side by AB, I have to divide the right side by AB also. Then my answer is C divided by AB. Let's get a little tougher. What's the first step here?
Subtract a from dx or c.
So I'm going to move the a to the other side, change its sign. Now I got that. Now what?
Divide dx by x. Or divide bx by...
First of all, remember I'm trying to solve for x. So you're saying divide this by b?
Yeah.
So that gives me this. Because remember, I have to divide both sides by b, and that means I have to divide every term on the right side by b. So I've got it down to x, but there's one big problem with this. And I went forth with it just to let you see why this is a huge problem. When I'm trying to solve for x, I cannot have any x's on the other side of the equation. And right now I've got that one right there. So I have not really solved it for x. Okay. So let's go back and take a different tact. Your subtracting the a was fine. But the next step is you want to combine like terms. Well, what that basically means is I want to gather all my variables that have x in them on the left side of the equation and everything else on the right. So let's subtract dx from both sides. What that's going to give me is bx minus dx equals c minus a. You with me? Now, how am I going to get the x out of this? I got a bx minus a dx. What can I do?
Divide the whole side by bd.
You're close. Factor out a greatest common factor. What's the greatest common factor between those two terms?
X.
That's what we want to do, is factor out an x. What's that leave?
bd.
B minus d. Remember, always be checking. In other words, is this the same as that? That's what I want to make sure, that I don't change it. And it is. In other words, if I were to take this and multiply it back together again, I would get bx minus dx. Okay?
Yeah.
Now notice what happens. Now I still got my c minus a over here. And now this is basically a coefficient to x, right? So if I divide both sides by b minus d, there's my answer. And notice there's no x's in it. In other words, I've got x is equal to this. But had to be relatively clever about it.
Yeah.
There's more than one way to solve these, and it's not always obvious which way to do it. Do another one like it. So first step.
Subtract bx.
Good. Next step.
Greatest common factor.
Which
Left
is
side. X.
okay. Now notice that I'm not doing something to the left side and the right side here. Because all I'm doing is rewriting that. Okay, so I can factor out an x, and what have I got left?
A minus b.
Not quite. Notice if I wrote a minus b, now check it. Are those two things the same?
No.
When you factor something, what you're doing is dividing every term by whatever your greatest common factor is. Okay, well, what do I get? I get a minus 1 minus b.
Oh.
That's how you factor. Is you basically divide whatever you decide is your greatest common factor, you divide every term by that. And that's how you determine what you have left. And since that's equal to c, now what's the last step?
Shoot, I forgot.
When you're solving algebra, what you want to do is, if you're solving something for x and there's other stuff with it, you want to do the reverse of whatever the other stuff is doing. Right now my x is being multiplied by this quantity a minus 1 minus b. So if I divide, now here I have to do both sides. So I'm going to divide by a minus 1 minus b, which means I got to do it over here also. Now that cancels with that, and I've got x equals this quantity, which is my answer.
Okay.
Okay. The next line.
Multiply.
Okay.
Ax.
Read the whole thing for me.
Ax equals b plus cx times 1.
Okay, I don't need the 1 anymore. In other words, b plus cx times b plus cx. Okay, now what's the next step?
Subtract cx.
And the next step.
Greatest common factor of
Go ahead and read.
which is x.
Go ahead and read
So
the
x.
line to me.
Then parentheses a minus c.
Good. And now finally, x equals what?
b divided by a minus c.
Good. You're a good learner. Right. Let's talk about systems of equations. For example, in other words, if I give you an equation like this, it only has one variable. Well, I can always solve for x. X is equal to 7, right?
Yeah.
In other words, if you have one variable and one equation, you can always solve it. But if I switch and put a second variable in there, like that, you can't solve that. There's only one equation and there's two variables. Notice that x could be 1, y could be 9, x could be 2, y could be 8. And the moment I start bringing negative numbers into it, then there's an infinite number of solutions. X could be -2, y could be 12. So there is not just one solution to this equation. There's infinite number of solutions.
Yeah.
Okay? But if I have another equation, here I'm going to pull it out of the book here. Let's say I have another independent equation that says x minus y equals 4.
Then it could be 2 and 2. Wait, no, it could be...
Hold on a minute. I want to teach this a little different. You may not have actually got this ever. What if the other equation is y equals 1?
And y equals 1.
Now, can you solve it? Can you solve, in other words, I now have two equations. There's equation 1, there's equation 2.
X equals 1, y equals 1.
Right. And you solved it by substitution. Okay? There are two methods of solving multiple equations. One is substitution, the other is elimination. Okay? This was substitution. We took the y equals 1, we substituted it into there, like that, and then we solved that equation, and so now we have x equals 1. That's how you got it. And we already knew y was equal to 1, so we have the solution for both variables using substitution.
Mm-hmm.
What if my other equation was y equals 3x?
Then x would equal...
Well, let's substitute. In other words, let's go down here and write x plus, instead of y, we're going to write 3x, right?
Mm-hmm.
That's why it's called substitution. And it's still the first equation, but we've turned it into, instead of having two variables, now there's only one variable, x. Well, what's x plus 3x?
4x.
So x equals 2 divided by 4, or 1/2. In other words, I've been able to solve it again by substitution. Okay?
Okay.
Now, notice that I used substitution whenever, and it doesn't matter which variable, but when one of the variables is fully defined like that, in other words, I can tell you what y is, it's 3x. So wherever I see y in the other equation, I'm going to substitute 3x. This is what I call fully defined. Okay? If, instead of fully defined, the other is an equation that's in the same kind of format like this, there's another technique I could use. In other words, I could use substitution. I could say x was equal to 4 plus y, and then substitute 4 plus y for x, and solve for y. So I could use substitution, but this is what's called standard format. Standard format is where your x and your y term are on the left side of the equation, and a number is on the right side. Okay? Whenever you have standard format, there's an easier method called elimination. And elimination is based on the fact that you can always add or subtract equations. And what I mean by that is the following. If I have A plus B equals C, and I have X plus Y equals Z, I'm always allowed to add those two equations, such that A plus B plus X plus Y has to equal C plus Z. See what I mean by adding them?
Yeah.
I can also subtract them. In other words, I could say A plus B minus X minus Y. Let's go through that just for a moment, just so you know why I said it like that. It's A plus B, basically, minus X plus Y. Well, over on the right side, it's going to be C minus
C.
But now if I want to remove the parentheses, I have to distribute that negative sign to both terms. So I end up with A plus B minus X minus Y equals C minus C. Okay? So, anytime you don't understand something that I am doing, make sure you stop me and say, whoa, back up a little bit. Okay? So I'm going to assume that if you don't stop me, you get what I'm writing.
I kind of don't as much as...
Okay, good. I'm glad you said something about it. Let's go back. If I'm subtracting, I have to subtract this bottom part of the equation from the top part. So it's A plus B is the top. There's the negative sign. And I'm subtracting X plus Y, right?
Yeah.
And then on the right side, I'm subtracting. Okay, now the next step would be to remove the parentheses. Well, I can remove the parentheses, these two, without affecting anything. Those weren't necessary in the first place. I only used them for clarification. But now, when I remove these parentheses, it does affect stuff. Remember, this negative sign has to be applied to every term that is being subtracted. Well, I'm not just subtracting X, I'm subtracting the quantity X plus Y. So when I remove this negative, those parentheses, this negative gets applied to that, so it becomes minus X, and it also gets applied to the plus Y, making it minus Y.
Okay, that makes more sense.
Okay. If that was a minus 2, then it would be minus 2x minus 2y. In other words, everything outside of the parentheses has to be distributed to everything inside of the parentheses. And then on the right side, it's still C minus Z. But the principle is important. You can add equations and you can subtract equations. Can't multiply equations.
Okay.
You can't multiply that times that and have it equal that times that. Or can I? I don't know. It doesn't apply. It's not going to come up. However, if we look at these two equations here, I want to use elimination because they're in standard format, both of them. So it's called elimination for a reason. It means after I either add or subtract them, one of the variables is going to be eliminated. Well, what can I do to eliminate a variable?
You can,
I could do either one. If I add the two equations, y is going to be eliminated. If I subtract the two equations, x is going to be eliminated. Well, addition is usually better for most students. So let's add the two equations. What do I get down here?
X plus Y minus X.
Well, go ahead and add them. You can add them piecemeal. In other words, add those two for the x's and then add those two for the y's.
2x plus nothing.
Exactly.
Or just 2x.
The y goes away, and that's the whole point. In other words, we now have 2x equals 6, therefore x equals 3.
Mm-hmm.
Now, you still have to solve for y. Well, if x equals 3, I go back into the simplest equation, plug in 3 for x, and I get y must equal minus 1.
Uh-huh.
So I've gotten my two solutions, and I have not used substitution. Well, I used substitution to solve for the second variable, but I solved for the first variable by making one of them go away. And notice that I could have subtracted these. It just solves for the other variable first. In other words, if I subtracted x minus x is 0, y minus a minus y is what?
Y minus another one. It's negative y. Negative 2y.
I got y minus a minus y.
Oh, then it's 1y. Or 2y.
2y, exactly. So, I got 2y. On the right side, what do I got?
You have 6.
Subtracting them now, remember.
Oh.
Remember, because you can do either one. You have to decide which you're going to do, and then do it to both sides.
Then it's going to be
2 minus 4.
Negative 2.
So, y equals negative 1. In other words, I get the same y value, and now if I go back and plug negative 1 in for y, I'll solve for x, and x will be equal to 3.
Okay.
So I get the same solution regardless of whether I added these equations or subtracted them. But this is a little bit of an unusual problem. Usually you need to do one or the other, not either one. In other words, in this case, I can eliminate a variable by either adding or subtracting them. But most of the time you can't do that. Let me put up another one here. Again, it's in standard format. When you see standard format, think elimination.
Uh-huh.
So how can I eliminate a variable? By doing what?
Adding.
And if I add them, I'm going to have 4x plus 4y. I don't eliminate a variable.
Subtracting.
Subtracting works. What's the next, what goes below the line here?
Nothing.
What's y minus 3y?
Oh, yeah. That would be 2y.
Negative 2y.
No, negative 2y.
And what's 3 minus 6?
Negative 3.
So you end up with y being what?
2.
We have to divide both sides by negative 2. In other words, here's what we're going to do. We're going to divide that side by negative 2, which means I have to divide that side by negative 2. So y ends up being 3/2, positive 3/2.
Uh-huh.
Okay. Now, let's look at this same problem again. And let's say we don't like subtraction. We want to be able to add them. Well, just like any equation, I can do whatever I want to one side as long as I do it to another. Well, I'm going to take this top equation and multiply it by negative 1, which means I have to do the same on the right side. Okay. And now my new equation 1, let me erase this line here. My new equation 1 here's my equation 2, is now minus 2x minus y equals minus 3. You see what I did?
Yeah.
Now, I'll cross this out and deal with equation 2 and 1. I've changed equation 1, but I haven't really changed it. It's still the same. So I can now add these two things together and eliminate x. I eliminated x before, but notice this is a little bit easier arithmetic. 3y minus y is 2y. The x's go away, and I'm adding 6 and negative 3, so that becomes 3. So now I still end up with 3 halves, but I didn't have as many negative signs to deal with.
Yeah.
So a lot of people will automatically do this step where they multiply the left and the right side by a negative number so that they can add the two equations and they don't have to subtract them. And there's nothing wrong with that. That technique is perfectly fine. Again, standard format, so you want to use substitution or elimination?
Elimination.
What variable are we going to eliminate, and how do we do it?
You were going to eliminate the x by adding.
By adding, okay. So what's the bottom?
6y.
Equals?
6.
So y equals 1. And then whenever you use elimination, you always solve for the one variable that didn't get eliminated. So you always have to then go back and use substitution to solve for the other variable. And you can choose either one of these equations to solve for x. It doesn't matter which one. Both of them will give you the proper answer for x. I usually use the one that has positive coefficients, low numbers, and that's this one here. That's the one I would plug my y equal 1 into. So I would end up with 2x plus 3 equals 0. 2x equals minus 3. X equals minus 3 divided by 2. Okay. Now, a little bit trickier. Standard format, so I still want to use elimination. But notice I can't add or subtract these and eliminate anything.
No.
So what can I do?
Multiply a side by -1.
Let's call them equation 1 and equation 2. If I multiply equation 1 by a -2, that's going to make everything perfect. Watch. In other words, I'm going to multiply this side by -2, which means I have to multiply that side by -2. You can never forget that principle in algebra. You can do anything you want, but you got to do it to both sides. Okay, now my new equation 1 is minus 2x. What's the rest of it?
Plus y.
What's minus 2 times plus 2y?
Just y?
No, we're multiplying.
Oh, then it would be
minus 4y.
Yeah. In parentheses.
Okay. And
Equals
what?
18.
Minus 8.
Negative 18.
Okay. Now, I got two number ones here. Let's cross that one out because we don't need it anymore. We've gotten it into a form where I can now eliminate a variable. What's the next thing to do?
X. So then you subtract.
You don't need to subtract. I can add.
Oh, yeah.
In other words, if I add these two things, I'll eliminate x. If I subtract, I'm going to have 4x down below. So I'm going to add the two equations. What goes below my line?
Negative 7y equals negative 14.
Which makes y equal
negative 2.
Positive 2.
Positive 2.
So I have negative 14 divided by negative 7. Negative divided by negative is always positive.
It's a positive.
Yeah, that's a good place. Let's do a little bit of A plus. Hold on a moment. Let me pull it up. Where did I put it? Right. I gotta get my keyboard for this. You holler out the answer, I'll write it in.
Negative 50. Oh, 3. So positive 3.
Always turn, hold on a minute. Always turn subtraction problems into addition problems. Here's what I
should be negative 15.
Yeah. In other words, what I have is a negative 6 minus 9. Well, that's the subtraction sign. Okay? Always have to know whether you're looking at a negative sign or a subtraction sign. Well, if I'm turning it, in other words, I can write this like this also. That's still the subtraction sign. But if I turn it into an addition problem, then I change the subtraction sign to a plus and change the sign of what was being subtracted. Now I got negative 6 plus negative 9. Nobody misses that. Everybody gets that. Only when they look at it as a subtraction problem that confuses a lot of people. That's one of the most missed arithmetic problems going, is when you have a negative number subtracting really a positive number. Or you can always look at this and just go ahead and put the plus sign out there, like that. In other words, you could also say that it's really negative 6 plus negative 9. It's the same problem as negative 6 minus a positive 9. All right, let's go back to math A plus here. Incidentally, you can talk to your dad about this, but if you find hour-long sessions are hard to focus for the whole hour,
I'm just really kind of tired because I've had a really, really long day.
I understand. But when I asked you last time about it, you said you tended to zone out a little bit more on the online session. And I get that. An hour is a lot. Most students, I would recommend they actually do 2 half-hour sessions rather than 1 full-hour session. Now, I can't really do half-hour sessions when I'm coming to your house, but if we're doing them online, it's just as easy for me to do 2 half-hour sessions as it is to do an hour session. And
So like 2 half-hour sessions within a week?
yeah, instead of 1 full hour session in a week. And that's an option you can choose. And whether you want to do it or not, it's totally up to you. Like I said, maybe you want to talk to your dad, maybe you want to try a half-hour session sometime, see how it goes.
Okay.
Most of my students find half-hour sessions a lot more palatable. They can stand them much easier. The half hour goes by pretty fast. An hour is a long time for math. Now,
Okay.
the other side of that coin is that when you get into school, you're going to be taking hour-long classes, and the tests are going to be hour-long tests. So there's a part of you that wants to build up your mental endurance, so to speak, so that you can go an hour at math. So it works both ways, but I do find that most of my students would rather do 2 half-hour sessions than 1 full-hour session. You can decide on your own, and just we'll deal with it however you want to decide to do it. But
Okay.
let's keep doing this.
-6. -88.
Oops.
-15.
Huh. They're not real creative, are they?
-72.
Good. You know what I notice?
What?
Much better on these flashcards than you are when we go to solve algebra problems.
Yeah.
Do you notice that also?
Yeah.
Why is that? You need to be able to make the leap to the algebra problem. In other words, this problem here is identical if I write it the following way. Right now it's 4 minus a -8.
Which is 12.
What I'm saying is that if I had 4x minus a -8x, you're less likely to get that. And yet it's the same problem, right? You're doing 4 minus a -8, so it's got to be a +12, and the x goes along for the ride.
I think the flashcard just helps make it look a little more simple.
Yeah, I think that's probably true, and I've noticed it with other students before also, that they get really good at this, but then when we go to the algebra, they're not as good.
3.
Hold on, you're adding a -3 to a -6.
Oh, then it's
There's no subtraction signs here. Both of these are negative signs.
Oh, I thought that was a subtraction sign.
No.
Oh. Of 9. -9.
-9. Always give me the plus or minus first, because that's what I want you to think about.
1.
To think about that plus or minus. That's as important as the number combination.
1.
Good.
126, right? No.
Well, the way I'm going to do this is I'm going to take 10 times 12, which is 120, and then I'm going to add
124.
So it's got to be 120 plus 12, 132.
120. 132. Oh.
Right, 120 plus 12. You see how I did it?
Yeah.
In other words, first of all, I multiplied it by 10. I kind of do it backwards of the way they teach you in school. I mean, I know how they teach how you to do this manually, but if I'm trying to do this in my head, I'm going to say, well, what's 10 times 12? Well, 10 times 12 is 120. That's easy. And I got one more 12. So I got to add 12 to 120, so it's 132 plus or minus?
Minus. 1.
Turn it in. Now in this case, this negative is not a negative sign. Notice it's not close to the number either. It's a little further away from the number. That's a subtraction.
Oh, so then it will be negative 8 plus negative 9, basically.
Negative 17, exactly. See how they have the subtraction signs out front and they have the negative signs right next to the number?
6.
Good.
Negative positive 35.
Good.
Yay.
I think you said 8.
Yeah. Oh, sorry. 2. Negative 4 plus negative 9.
Correct. Now notice how this is easier than if they left the plus sign out of there. The same answer, it would be negative 9 regardless. But it's a lot easier to see when it's an addition problem rather than a subtraction problem. In other words, if I erase that positive sign there, then I'm going to have negative 4 minus 5, which is the same as negative 4 plus negative 5. So it's minus 9 whether they put that plus sign in there or not.
Negative 16.
Good.
Negative 14. No, positive 14. 3. Oh, negative 1. 1.
Positive into a negative.
Oh, yeah, negative.
Negative 1.
Negative 13. Negative 11. 0.
Good.
Negative 1.
Okay, 1 into anything is the anything.
Oh, yeah.
Okay, so it's got to be the negative 3 has to be the answer. In other words, no matter what I divide something by, if I'm dividing it by 1, my answer is whatever was inside the division sign. Always.
1. Seven.
Get 3 in a row and I'll let you out early.
5.
That's 1.
16.
Multiplication.
Oh. Yeah, I did 4 times 4.
So 4 times 4 is 16. 4 times 8 has to be twice that much.
Negative 32.
Positive.
Just 32.
Right. One more.
Negative 11.
All right. Just a second. I lost my thing. Okay. Sounds good. I will be having an online session with your brother at 4 next Tuesday and at 5 with you.
Yeah.
And like I said, if you decide you want to try the other, we can do it. If you can work it out with your schedule. Usually it's easier to work in half-hour sessions than it is hour sessions in terms of matching schedules. You can almost always find a half-hour session somewhere.
Uh-huh.
Okay? So
Wait, 5 with me online? Oh, yeah.
Yeah, and I will call Bolton at 4 o'clock next week to help him get the software set up on his computer. In other words, I'll do the same with him as I did with you the very first session we had.
Yeah.
Where I call him and work him through installation of the software and get his audio working, and then from there on I just email both of you text meeting ID numbers.
Okay.
Okay?
Yeah.
All right. Have a good week. I will talk to you next week.
Okay.
All right. Bye-bye.